Good afternoon, class. Today I'm going to discuss on how are you going to analyze your items using the SPSS factor reduction or factor analysis. Okay, first what we need to do is to find the folder or file. Now we need to click the file, which is to open, and then try to click the specific file where your specific storage where your file is. So here I'm going to click this one where it is a USB where I can find my file. Now here I'm going to look for site 12 because that's the specific folder that I save my file or my document. So site 12, okay. So here's site 12. Now, I'm going to locate for the file 3.1, worksheet number 8. I'm going to double click this one. Okay, so you would see that there are no files coming out because I need to change the files of type and look for Excel. Okay, so here I have several files under Excel. Not what I'm going to do is to choose Abiola's extraversion scale. This is what we're going to use for our demonstration. Okay, and you click open. Okay, so lalabas ito. Now, all you have to do is, if there is no click here or no check here, you need to check it. No, so read variable names from the first row of data, and you click OK. And then your files will come out. Now here, what we're going to do is to analyze, and then click dimension reduction, and then you click factor. Now, you're going to transfer the items or the data for items for item 1 to 20 and transfer it to variables. And then you have to click descriptive, click initial solution, and then continue. And then for the extraction, you need to click unclick the unrotated factor, and you just click the based on eigenvalue greater than 1. There are no fixed number of factors since it's unidimensional, but if you have several factors, you can try to click here and then encode the number of factors. However, on the case of Babiola, as our sample data, there is no fixed number of factors. So we just click the based on eigenvalue greater than 1.0, and then the maximum iteration for convergence is 25, and then we press or click continue. Now, for the rotation, we have to click the variable maximum rotation, and then the display is the rotated solution, and then the maximum iteration for convergence is 25, and then click continue, and then we click OK. Now here we are directed to the output where the items are analyzed, and we have to look for the rotated component matrix. Now we try to copy this by clicking the table and then click copy. Okay, let's repeat that one. So all you have to do is to click the table, and then you press copy, and then go to Word. Let's open the Word, blank document, and we try to paste here the table. Okay, so you have here the table. What we're going to do is to insert a text box. So I'm going to click here the insert, and then I'm going to look for the shapes because this is where I can find the text box. And then I'm going to insert here the text box. And then I'm going to write here item analysis decision. Okay, so let us try to analyze the items. So here, what we're going to look for are factor loadings or number loadings. Here, the factor analysis or the factor reduction process in SPSS will try to suggest to you that based on that specific data or scale, there are 4 factors that you can extract. Now, what you have to look for are factor loadings. These are the factor loadings with a value of 0.25 and higher. Now, let us see, for item number 1, uniqueness of items would show us that the factor loading is loaded only on a specific factor. But on item number 1, there is a value or factor loading of 0.25 and or higher on factor 1, factor 2, and factor 3. If there are multiple loadings of factors of multiple factor loading of an item on several factors, the decision that you should do is to reject the item. Why do we reject the item? Because that item does not suggest uniqueness because it was loaded on several components or factors based on the SPSS or the factor reduction analysis. Now, for item number 2, again, we have to look for factor loading 0.25 and above. And you would see for item number 2, 0.25 and above value is only seen on factor 1 for item number 2, which means that item 1 is unique because it only loaded on factor 1. Now, what are we going to do on that item? We are going to retain that item because it indicates or it shows uniqueness because it only loaded on factor 1. Okay, now for item number 4, or for item number 3, you would see that the item is loaded on component 1 or factor 1 and component 4, which means that the factor or the item has multiple or double loading. Now, if this is the case, if there is double or multiple loading, again, we try to reject the item. Okay, so for item number 4, you would see that component 1, component 3, and component 4. Item number 4 is loaded on those components, which means it has a double or multiple loading. So our decision is to reject the item. Okay, so for item number 5, you would see that item 5 is loaded on component 1. We disregard the negative sign. What we look for are values greater than 0.25, 0.25 or higher and higher. So here you have item 5 was loaded on component 1, component 3, and component 4, which means that there is a double or multiple loading, and what we do is to reject the item. Okay, so for item number 6, it is also a multiple loading because it was loaded on component 2 and 4, and that's what we do. Now, for your assignment, for worksheet number 9, you are going to do, I'm going to send you the rotated component matrix and what you are going to do is to make a decision on the items that you created. That is why it is important that when you create items for a specific scale or specific, if you do your own test or scale, you need to do more items because there are possibilities using the factor analysis that items can be reduced. And if you only have few items, it might be that at the end, there are no more items left after the factor analysis. So this is how we do the factor analysis. And if you only have, if it is a unidimensional on your original plan, but however, based on the factor analysis, it was loaded on several factors. And at the end, if you found out that it was loaded, say, for example, in component 1 and component 2, there are items loaded on component 3, meaning you have to create name for factors because there are items that creates several factors or factors now based on the factorial analysis. So thank you very much, class, and have a great day.